Hello, my name is Prashant Sengadu Suresh. I'm the first author on this paper, Open Human-Robot Collaboration using Decentralized Inverse Reinforcement Learning. Many HRC domains contain only a few subtasks that require dexterous manipulation. And yet, a closed system often models a task with a fixed set of agents from start to finish. This in turn forces the human to stay throughout. Alternatively, an open system allows agents to enter and exit the task as needed. This means that the robot can easily perform simple repetitive tasks and only call the human in when needed. An open system generates a human-centric solution that allows the human to work on many tasks simultaneously and efficiently uses their time and energy. In this paper, we make three key contributions. We propose a novel decentralized multi-agent model that allows for agent openness. We propose a novel IRL technique that learns a reward function and a set of policies for each participating agent from expert demonstrations. Finally, we evaluate it on a simulated firefighting domain and a human-robot collaborative furniture assembly domain. Our first domain is a simulated firefighting scenario where the goal is to extinguish 3 fires in a grid. One agent starts the task and based on the learned policy calls the other agents in. The active agents then collaboratively extinguish all 3 fires. Each fire has a cost associated to it based on its current intensity, and each active agent receives a step cost. Extinguishing each fire yields a positive reward. All agents share the same rewards and the costs. Our second domain is a real-world human-robot collaborative furniture assembly domain. Here, the goal is to assemble a table in different orders using its components. In each order, the robot can independently position the parts on the base, but requires human assistance to screw them in. Following the learned policy, the robot begins assembling the parts, and when it reaches a point where it requires screwing, it uses an on-screen pop-up to call the human for help. The human screws the part in while the robot holds it in place. The parts are tracked using April tags, and the human state is tracked using hand tracking. The two videos here show two different variations of the table assembly task. Notice how the human is called in at different points based on the assembly variation. The parts are positioned independently by the robot, and the human screws the part in while the robot holds it in place. Notice that the part that the human is working on is tracked using their hand position and the April tag on that part. To conclude, our pilot study with 5 human subjects shows that across both task variations, around 18.39% of the human's time was saved. All subjects provided high scores for robots' predictability and contribution. Thank you.